Alright, let's tackle the problem that's on the board. Find the exact value of cosine theta if theta is acute and tangent of theta is equal to 5 over 12. Right? Since tangent of theta is 5 over 12, this is not one of the special angles that we know. It is not a multiple of pi over 6 or pi over 4, so we have to tackle this problem without thinking about our special angles. A nice way to do it is to just use a reference triangle. Theta is acute, so I'm going to use a reference triangle in the first quadrant. And on this triangle, the opposite over the adjacent has to give us a ratio of 5 to 12. Well, let's pick the triangle that does it the most plainly, right? Let's pick a triangle with an opposite leg of length 5, adjacent leg of length 12. To compute the cosine then, I just need to know the hypotenuse by the Pythagorean theorem. The hypotenuse squared is 5 squared plus 12 squared. So 25 plus 144 is 169. The hypotenuse is a length, so we are going to use only the positive square root of 169, which is 13. So cosine of theta, we're in quadrant 1, so it's going to be positive, and it's going to be 12 over 13. Let's do one more. Let's say the sine of theta is negative 4/5. And theta lies in quadrant 3. So I'm going to use a reference triangle in quadrant 3. Right, so I'll use a little theta prime there just to make sure that we understand that angle right there is not theta. Okay? But we can use this triangle to answer our question. Right, the sine of theta is negative 4/5, right? Well, the negative is kind of taken care of by the fact that our reference triangle is in quadrant 3, so we're not going to worry about that too much. But the ratio for our reference angle of the opposite over the hypotenuse has to be 4 over 5. Right? So to figure out the cosine using this reference triangle, I'd like to know the length of the adjacent there. So let's see here, Pythagorean theorem. Oh, let's just call that length A. A squared plus 4 squared is equal to 5 squared. So A squared plus 16 is 25, making A squared equal to 9. So A is the positive square root of 9, which is 3. So this reference triangle tells me everything I need to know in order to evaluate the cosine, or any trig function really. I just need to keep in mind of what quadrant I am in the plane. Right? So cosine of theta, well, I'm going to use the adjacent over the hypotenuse, but because I'm in quadrant 3, cosine is going to be negative. So this is negative 3/5.